I'm Anil Kumar, and in this video, we are going to discuss binomial probability distribution in details. We have few videos talking about Bernoulli's trials, binomial distribution, but this is the one which kind of combines all the concepts which we have learned so far. Now, whenever we have binomial distribution, we should remember it begins with n Bernoulli trials. So we have n number of Bernoulli's trials. Now, when we say Bernoulli trials, what do we mean? We mean four things. Let me summarize these things also as we move along. The four things which we mean are: one, we have always fixed number of trials. We have fixed number of trials. So that means we have finite number of trials. So we'll define a variable for this fixed number of trials. We call it a parameter n. Right? So that is the parameter n. And then we should know that all these trials are independent. Independent trials. I hope you remember when we were working with probability, independent trials, if we do one after the other, then their probabilities get multiplied. And in independent trials, the probability of each event remains same. So it is not really affected. So the repeated trials are not affected by the initial trials. For example, if you are drawing a ball from a bag of number of balls, then we do replacement of the ball. If we withdraw a card from a pack of cards, we replace the card. In that case, we maintain the probability experiment as such, and where every trial is an independent trial. Okay. Then, in any Bernoulli's trial, we have only two outcomes. We have only two outcomes. And these two outcomes are success or failure. Right? This is very important. These two outcomes are success or failure. So always there are only two outcomes. And then we have that the probability of success, so it's a probability of success is same in each trial. And normally we associate lowercase p parameter for this particular probability, right? So whenever we're talking about binomial probability distribution, we also use the terminology b for binomial, n for number of trials, comma, p for the probability of success, right? Probability of success, which is probability of success of each trial. That is very, very important to understand. So these are the parameters for Bernoulli's trials. And when we talk about binomial probabilities distribution, in that case, what we do is we define a random variable. So let me add now new things, which is a random variable x. What is this random variable x? This random variable x is actually number of successes in n trials. This is very important. It is number of success in n trials. So let us say we toss a coin 10 times and we're looking for 7 successes, right? In that case, this variable will have a value of 7. So it is always a real number. So it is always a real number, and it represents number of successes in n trials. That is what it represents. And there are a few more terms which you will come across. And then the one term is probability of each of that success. So we call this as the probability of getting n number of successes. So we have probability of success of x equals to little x. So because where little x is those numbers, do you understand? Numbers could be 0, 1, 2, 3, 4. So probability of little x, so which we write as, let me write down here, capital P, right? X equals to little x, or sometimes only small x. So that is the probability of number of successes. That is what it is, and that is actually the probability distribution. So it gives you the distribution also if you put it in tabular form, or if you put it on the graph like a histogram, you can see the distribution also, right? Now let us take up an example. So what I will do now is create a random probability experiment. So let's talk about an experiment and we'll see how these values are related. So I will talk about a random probability experiment. So in this experiment, let us say we roll, so experiment is to roll a fair die, which is 6 faces, right? 6 faces. 3 times. So roll a fair die 3 times. So if you roll a fair die 3 times, so fair die, we're trying to say this is my fair die. Correct? And we are going to roll this 3 times. So it has 6 faces. The numbers are 1 to 6. Now, let us define the random variable first. So whenever you're talking about binomial probability distribution, you should begin by defining the random variable. So in our case, we'll say the random variable x is number of, so we'll say what is x. X is the number of successes. X number of success. But we didn't define what success is. X is the number of success. That is always the random variable x. What is the success in our case? So we'll say success will be, let us say, when you throw a dice, you get the number 6, right? So get 6 as the success. So if I roll a die and if I get 6, I will call that to be a success. Is that fair enough? So we'll do that. So that means what is failure? Well, failure is what? Failure is not 6. Is that okay? Not 6. That means it could be any other number. That is to say, it could be 1, 2, 3, 4, or 5. Is that okay? So failure is not 6. And success is to get 6. Now let's get back to all these parameters. So the first parameter we talked about is number of trials, and we are saying number of trials is 3 times. So we have here number of trials 3 times means n equals to 3. Is it okay? So n is 3. Now success is getting 6. So lowercase p, which is probability of success in each trial. This p is in each trial. So we have probability of success, let me write down here, p as equals to 1 out of 6, right? 1 out of 6. Since there is only one number which is 6, and probability of failure q will be 5 out of 6 in our experiment. Is that okay? So this is the experiment which we are performing, correct? Now, we will see what is the probability of getting 0 success, 1 success, 2 success, or 3 success, right? So what are the values which x can have? Number of successes is x, right? So in our case, x can have either 0, that means no success at all, or 1 success, or 2 success, or 3 success. So these are the values x can have, and what we need to perform is we have to find for each value of x the probability of each value of x. This is what we need to find out. Once we find out this, that gives us probability distribution. Is that clear? So that is the basic concept which we are going to use for almost all the questions with binomial probability distribution. Is it okay? Let's begin, right? Let's start this question all over again. So now our parameters are, there are 3 trials. So n equals to 3, p. In each trial, the probability of getting 6 is a success, which is 1 over 6, and q, which is 1 minus p, is 5 out of 6. Is that okay? So that is given to us. Now, let me make a table here to show possible outcomes. So what are the possible outcomes in our case? Outcomes for the random variable x, do you see? X can have values as 0, 1, 2, or 3. Is that okay? Only 3 trials, so you can get 6 0 times. That means you don't get 6 at all in 3 trials. Or you get it once, or you get it twice in 3, or all 3 times you get 6. Correct? So for each, we'll try to find the probability, right? So this is capital X, the random variable. This is the probability of each one of these, right? So which we are going to work out. Correct? Now let's look into the sample space, right? So let's do the calculations here. Let's do the calculations. I need a lot of space here. So we'll do the sample space. Let's say, what are the possibilities? So when I'm throwing the dice 3 times, I could get 6 or I could not get 6. These are 2 things for me, right? So it is black and white, success or failure. So if I get 6, it means it's a success. If I get any other number but 6, it is a failure, right? So let me write down success with S. Okay, so let's begin with success. No harm, right? Success. So let us say we get all 6s. 3 trials, all successes. Do you see that? All success. That means 3s. That means the number goes here. 3s. Do you see that? Other thing could be we could get 2s but 1 failure, right? So 2s and 1 failure. Now this failure could happen in the different positions, right? Second trial could be a failure, or the first trial could be a failure. Is it okay? So 2 successes and a failure. Well, we could also have 2 failures and a success. So we could also have 2 failures and a success. This success could be last time or in middle, or this is a failure. 2 failures we're looking for. Okay, so let me rewrite. We don't want to do a mistake here, right? So 2 failures. Okay, and then we could have success and 2 failures, or we could have all failures. So these are the 8 options in the sample space. Now clearly you have either 3 successes, or you have 2 successes, or you have just 1 success, as you can see in some of them, right? Just 1 success, like here, correct? 2 failures and 1 success, or no success at all. Is it okay? So that is the situation. Let's find the probabilities. We know all these are independent events. Every time you throw the dice, either you get a 6 or you don't get a 6. And probability of getting a 6 is 1 by 6. And probability of not getting a 6 in each trial is 1 minus 1 by 6, which is 5 by 6, right? So now let's find the probability for this random variable x to have no success at all, right? That means 0 success. That means failure, failure, failure. Do you get the point? So this is failure, failure, failure. That is the situation, correct? So that is the option. So that is the only option. And we need to find the probability of this. So what is the probability of failure, failure, failure? Since there are 3 independent events, Q, 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 right? So let me write Q, 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 or We'll write q cube for the time being. How about probability for x being 1? That means one success in 3 trials. That means probability of which things? So one success in 3 trials. So it could be one success, 2 failures like this, or the success could be in the second trial, right? Or the success, could be in the 3rd trial, but there is only one success. Do you see that? So probability of each is how much? Probability of this will be success is p, right? So we have p q square. This is q, right? Times q, or means plus. So it is failure, success, failure, plus failure, failure, success. Is that okay? So that gives me 3 terms which have p and q square. So let me write 3 q square p. Is that okay? So that is what we get for 1. Probability for random variable equals to 2. That means 2 successes, right? So we could get 2 successes and a failure. We could get success, failure, success, or we could get failure, success, success, right? So that is to say, success is p for us. So p, p, and q plus p, q, p plus q, p, p, or 3 times q, p square. Is that okay? And last is x is equals to 3. That means probability for success, success, and success. 3 successes. Is that okay? There's only one case for this. And success, success, success means p times p times p, or pq. So we have got the probability density. This is what we call probability density, right? Or probability distribution, I'm sorry. This is what is called probability distribution for each. So for 0, what did we get? We get q cube. For 1, we get 3 times. So 2 failures and 1 success. For 2 success, we got 3 of those terms. So 1 failure, 2 success, square for 2. And in this case, 3 success p cube. That is what we get. Does it remind you of something? Q cube times 3q square p times 3qp square times this. Now, it does remind us of something. How about q plus p whole cube expansion? So that is a binomial terms, q plus p, and if you cube it, you get this plus this plus this. Also, q plus p is how much? Q plus p is 1. We know q plus p equals to 1. So 1 cube is also 1. So some of these is, what we are saying is, some of the probabilities of all these x's is 1. Some of these probabilities is 1. Do you see that? So that is also satisfied. Of course, in this particular experiment, all the values which our random variable can take are considered here, 0, 1, 2, and 3. So some of their probabilities should be 1, so that is satisfied. As you observe here, q plus p whole cube is equal to 1, since q plus p is 1. Sum of all these probabilities is 1, as it should be, since the random variable, all the 4 values, when you add their probabilities, you should get 1, right? So binomial probability distribution is because you could predict the probabilities of each number of successes directly. Do you see that? These terms are coefficients of the binomial coefficients. Do you see that? So, for example, this term is, we have n number of trials, nc2, nc1, nc0, and nc3c3, I should say. Is that okay? So what we have observed here is that all the terms which we get in our probability distribution are from the expansion of binomial theorem. Do you understand? Do you remember that? So, if I have q plus p to the power of, let us say, any number, right? N, right? So n number of trials, q plus p to the power of n. Then its expansion, which if we are interested in, let us say, r number of trials, let us say, right? So any particular term x will be ncx q, or rather we can just say p to the power of x times q to the power of n minus x. Do you see that? So that becomes the general formula for x equals to any value. Let me write here, x equals to small x, capital X equals to small x. Do you see that? So the random variable x can have any real number, and in this expansion, for that particular real number, the probability will be ncx p to the power of x q n minus x. Do you see that? That is what we have kind of concluded from this particular video. We'll take up a proof of this later, but I hope that is absolutely clear, right? So now you can actually calculate these values, substituting p as 1 over 6, q as 5 over 6. So you'll get your values, and then you will have numbers to plot the binomial distributions, right? So at present I'm leaving it here without calculating those values, but you can do that on your own. The idea of this video was to understand how to relate our Bernoulli's trial with the random probability distribution, right? So with an example, a simple one, where we took n as 3, probability for each trial being fixed, trial after trial, as 1 over 6 success, 5 over 6, which is 1 minus 1 over 6 as the failure, right? And then we concluded that probability for 0 success is nc0, p to the power of 0, q to the power of 3, right? In this case, n is 3. Probability for x equals to 1 is 3c1, q to the power of 2, p to the power of 1, right? And for 2, it is 3c2. So 3 is 3c2, q to the power of 1, p to the power of 2. And this is 3c3 as the coefficient, which is 1. So that is what we conclude in this video. I hope you appreciate it. I'm Anil Kumar. You can always share and subscribe my videos. Thank you, and all the best.